Dear students, aromatization is an important reaction in organic chemistry where simple compounds change into stable aromatic compounds like benzene. In this process, molecules form ring structures with delocalized electrons, making them more stable. Aromatization is widely used in petroleum industries, medicine, production, and chemical manufacturing also. In this video, we will learn what is aromatization, how it happens, the catalyst used, and its industrial applications. So, let's understand the fascinating process of aromatization in a simple way. What is the aromatization? Aromatization means the process of forming an aromatic compound from a non-aromatic compound is called aromatization. That means aromatic compounds obtained from non-aromatic compounds like N-hexane, N-heptane, etc. Meanwhile, what is the aromatic compound? Aromatic compounds are cyclic compounds. That means having must and should ring-shaped compounds with alternating single and double bonds. That is called conjugate system or conjugate ring, and having stability due to delocalized electrons. What is meant by delocalized electrons? Let us see. So, to explain the conjugate system, first of all, we would learn about Huckel's rule. What is Huckel rule? Huckel rule is used to determine whether a compound is aromatic or not. According to Huckel rule, a cyclic planar or fully conjugate system must and should satisfy 4n plus 2 rule. What is 4n plus 2 rule? If suppose n is equal to 1 we substitute, then 4 into 1 plus 2, that is 6 pi electrons are obtained. That means if a ring having 6 pi electrons or 10 pi electrons or 14 pi electrons considered as an unsaturated compound or aromatic compound. For let us take an example, benzene. Benzene having 3 pi bonds. That means 3 into 2, 6 pi electrons. According to Huckel's rules, if a compound having 6 number of pi electrons, it is considered as an aromatic compound like naphthalene, toluene, etc. All these are considered as an aromatic compounds. So, to consider any compound is an aromatic compound, it must and should having conjugate system and delocalized electrons and must and should satisfy Huckel rule. Delocalized electrons means those pi electrons does not place or restrict to any one atom. It revolves all the carbon atoms present in the ring. This type of conjugate system is not found in open chain compounds, even it contains alternate double and single bonds. Hence, aromatic compounds can be obtained through this aromatization from non-aromatic compounds. What is meant by non-aromatic compounds? These non-aromatic compounds does not having alternate single and double bonds. What is a non-aromatic compound? Non-aromatic compounds having normal stability, no continuous conjugation, and may or may not having ring-like structures. And in non-aromatic compounds, electrons cannot move freely around the ring. These are maybe cyclic or open chains. No continuous conjugated pi electron system, and electrons are localized instead of delocalized. And non-aromatic compounds do not follow Huckel rules like aromatic compounds. Let us explain this non-aromatic compound with a simple example like cyclohexane. Cyclohexane mainly exists in a chair conformation which is non-planar in shape. Since there are no alternating double bonds, cyclohexane lacks a continuous conjugated pi electron system. As a result, there is no delocalization of electrons around the ring. Huckel's rule also fails in cyclohexane. Hence, cyclohexane is a non-aromatic compound. Cyclohexane and cyclohexene are also non-aromatic compounds. Now, aromatization in alkanes. N-alkanes, N means normal alkanes, that is hexane or heptane, etc. N-alkanes having 6 or more carbon atoms on heating to 773 Kelvin at 10 to 20 atmosphere pressure in the presence of oxides of vanadium or molybdenum or chromium supported over alumina getting dehydrogenated and cyclized to benzene. This reaction is known as aromatization or reforming. Why it is also called as reforming? Because aromatic compounds are formed from non-aromatic compounds. Hence, this is also called as reforming. Here, we consider few points in aromatization of alkanes. Here, more amount of temperature and high pressure are used in this reaction. Why these high temperature and pressures are applied in this condition? We will learn about this later. And in this reaction, N-alkanes means normal alkanes, there is no ring shaped in them, are converted to aromatic compounds. In this mechanism, an intermediate cyclic compound is initially formed and then dehydrogenation takes place and N-alkanes are converted to finally aromatic compounds. Let us explain aromatization with a simple example. N-hexane on cyclization in the presence of chromium trioxide or vanadium pentoxide as a catalyst undergoes cyclization forming cyclohexane as an intermediate product. On further dehydrogenation, cyclohexane converted to aromatic compound, that is benzene. Another example for aromatization is formation of toluene from N-heptane. N-heptane is a non-aromatic compound and a cyclic compound. It contains 7 number of carbon atoms. It undergoes cyclization in the presence of platinum or aluminum as a catalyst and high temperature and high pressure also. A methyl benzene is obtained as an intermediate product. On further dehydrogenation, toluene is obtained. Toluene is an aromatic compound, whereas starting material N-heptane is a non-aromatic compound. In this reaction, chromium trioxide, vanadium pentoxide and molybdenum trioxide acts as dehydrogenating catalysts. When hexane, which is a non-aromatic gas, passes through a tube containing the above mixture means vanadium pentoxide, chromium trioxide, alumina, this is mixture. Then dehydrogenation takes place and benzene, which is aromatic compound, is evolved. If we take N-heptane, then toluene is obtained. Toluene is aromatic and N-heptane is non-aromatic compound. Industrial applications of aromatization. Aromatization widely used in petroleum, chemical and pharmaceutical industries. In petroleum refining, converts low-octane hydrocarbons into high-octane aromatic hydrocarbons through this aromatization to prevent engine knocking and improve fuel efficiency.